If the green dots are rain droplets, the heavier the droplet density, the more will be collected through the aperture. Same principle applies to light. Each dot symbolizes a photon energy package. The higher the light flux is, the more energy collected per unit time, or, the higher is the collected power. The wider the aperture is, the more flux is collected, like the size of a solar panel. Determine the relationship between aperture size and net collected flux. Make a distinction between net collected flux versus flux density. And a conceptual distinction between incident flux density versus flux density distributed on the aperture. Intuitively, one would tilt the body sideways to minimize exposure to a splash. A solar panel would be tilted to have largest profile exposed to the sun. Use geometry to determine the collected flux versus the relative angle between the incident flux and the aperture normal vector. Illumination density or illumination light intensity is different from incident light intensity. Illumination or irradiance density on a surface depends on its orientation relative to the incident beam. This is known as cosine irradiance law. The sun power on any location on Earth depends on the day of the year, the time of the day. Assuming a clear sky, the sun power is proportional to the dot product, that is, the cosine of the two vectors, the sun light direction vector, such as incident flux vector S, and the Earth normal vector of that location, such as vector N. For a given location on Earth, as the Earth moves around the Sun, the angle between the sun light direction and the location normal vector, goes through a cycle of low and high. Low angle episode corresponds to summer, the maximum irradiance day is known as summer solstice. High angle episode corresponds to winter, and the minimum irradiance day is winter solstice. The inflection midpoints between the solstices are vernal and autumnal equinoxes. 3 cities at 3 different latitudes, one near the equator, the other 2 are opposite on the northern and southern hemisphere, display 3 types of solar irradiance characteristics. The city in the Tropic of Cancer has little variation year-round. The northern and southern hemisphere cities display large variation and that has opposite phase.